All right, guys, welcome back. This is the second video in the series for DMVPN along with MPLS VPN. So in the first video, what we have done is we basically set up our core network, which is your service provider network, in which we set up our 11 as our route reflector for all the PE routers. And we've also set up a switched environment where R1, R2, R3, R4, the 4 or 5 P routers are directly connected to each other. So although the route propagation is done through the route reflector, the actual data propagation, because the route reflector is not changing in the next stop, will be done directly from the P router to P router. So I have the ability to segregate the data plane traffic from the control plane traffic. That is already done in the previous video. You can watch that first video in the series to take a look at the service provider setup. Now, in this particular video, what our objective over here is to provide some type of security in our from the perspective of the customer side. So right now, I'm going to look at it from the customer side, where I have a customer with 5 sites, and I want to set up a DMVPN setup. Now, if you don't know how DMVPN works, you might want to take a look at my DMVPN video. My objective over here is to use DMVPN from the perspective of the customer, making sure my routes, my my customer routes are not seen by the service provider. I'm not going to go into the basics of DMVPN over here. I would suggest that, as I said, watch my DMVPN video for that. My objective over here is to show you how it works in conjunction with your MPLS VPN, and more importantly, from the perspective of the front door VRF and the internal VRF perspective. So let's say if we were doing a normal MPLS VPN in which I had customer sites over here, customer routes over here, I would have been propagated to my PE router. So the PE router would be aware of all my internal routes. Let's say I want to segregate that routing completely from my PEs, the provider edge, my service provider. I want to keep it segregated. Not only that, I want to be able to encrypt it as it goes through the service provider cloud. So what I'm going to do is I'm going to create a VRF over here. Obviously, I'm going to create the VRF on my PE router for the customer. So that is your customer VRF. Let's call this class A. That's on the PE side. But on the customer side, so I'm the customer consultant over here. What I'm going to do is I'm going to keep a VRF over here called, let's call it FVRF, front door VRF. This front door VRF is going to have the outside interface, and I'll create a loopback over here. Let's say 10.1.1. or 10.6.6.6. Yeah, let's do 10.6.6.6 over here as a loopback on router 6, 10.7 over here, 10.8 over here, 10.9 over here, and 10.10 over here. This loopback, I'm going to advertise in my PEC routing protocol. Let's use BGP as my PEC routing protocol over here, so that the only route that the routers over here are aware of, the PE routers are aware of, is that 10.10 route that I have propagated to the PE routers. The PE routers get it to all the other customers. So that 10.10 or 10.6 or 10.7 route is going to basically be my tunnel source for my DMVPN. I'm going to put the tunnel, I'll create a tunnel, a DMVPN tunnel, which is going to advertise my internal networks. Let's say I have a 192.168, let's say 6.0, and I'll put a 172.16, 6.0 over here. Same thing over here for 7, 8, 9, and 10 inside my DMVPN. I'm going to advertise that through my DMVPN, which is going to use the front door VRF just for the purpose of connecting. But that tunnel and the internal routes will be in a separate VRF. I'll call that VRF internal. So the purpose of the front door VRF is just to provide reachability for the tunnel interface. My internal VRF is the one that will actually contain what? The routes that I want to advertise through my DMVPN tunnel. On the DMVPN tunnel, I'm going to run EIGRP as my AS, as my routing protocol in AS 100. On the outside, I'm going to run BGP as my PEC routing protocol. On the tunnel interface, I'm going to show you a command that allows the tunnel reachability to be provided by using the front door VRF. That's the front door VRF concept that I'm going to get around over here. So the first thing, let's set up my CE routers, R6, 7, 8, 9, and 10 with those front door VRF, and also put those outside interface and my, my loopback, we'll keep loopback 0 as the interface that is going to be used for tunnel reachability. So let's bring my devices up over here. I'm going to bring my notepad up because whatever I'm going to do over here is going to be replicated onto the other side. So it's easy to do that. Let's start with R1. That is my PE router. To create the VRF, we'll say VRF definition, bus A. We'll say RD is 100:1, address family, IPv4, and we'll say route target, both is 100:1. And then I'm going to go to my interface, E0/2, which is this interface over here on router 1 towards 6. We'll say VRF forwarding, cust A, and set the IP address as 192.1.16.1. And not only that, I am also, so my first step, I should also put that in. Step 1, configure the PE routers with the VRF and PEC routing. That's my first step over here. Copy it. Do it later on over here. R1 is done. The other thing that I want to do is my PEC routing. I'll say it is address family, IPv4 VRF for .A. And the only thing I need to do over here is the neighbor. I'm going to say 16.6 for router 6. Remote AS will keep it 65006. So whatever the number is over there. That becomes R1. Let's see if that config works. Looks good. 16.1, 16.6, remote AS is good. My local AS is good. Brilliant. So now let's do R2. I'm going to make some changes for R2. This part remains the same. The IP address will be 27, 2 and 7, 27.2 on my side. And on the other side, I'm going to say it is 27.7 with an AS number of 67, 65007. Get that up. So cust A, put it under the interface, 27.2, and the neighbor. Perfect. Moving right along. R3, that is going to be 38.3. And the remote one is going to be 38.8, and this is going to be 65008. You understand that? 38.0.3.8. Let's go to router 3. Looks good. Now let's do 4. It's 4 and 9, I believe. 4 and 9, 49. So this part is the same. 49.4. And this is going to be 49.9, and this is 9. Almost there. Four is done. This is 55 on 5, 55.5 and 55.10. So 55.5, and this is going to be 55.10, and the autonomous system is 650010. That should take care of my PE routers. Done. So my PE routers are done. Now let's take a look at what I'm going to do on the customer edge routers. On the customer edge routers, first thing that I'm going to do this. So this is the PE side. Oh, that's what step one, yeah. Now let's do step two over here. Step two, configure the CE routers with the front door VRF and a loopback for the DMVPN tunnel source / destination. All right, run BGP as the PECE protocol to match the previous step. So at this point, at the end of this step, I should have reachability between the loopbacks that will form the down source down destination for my DMVPN. That's the intention over here. So router 6 is my first what do you call it, CE router, VRF definition. I don't need, actually I do need an RD. I am going to specify my RD as R6. What was I doing over here? R6 is this guy. Configure the CE router with the, okay, good. That is done, that is good. I don't need this. Okay, so what I'm going to do on R6 is create the VRF. I'm going to call this VRF FVRF, just a name. Give it an RD value. I'm going to say 65006:1. I don't need a route target because I'm not actually doing any MP BGP over here. So I do need an RD because I'm going to run this inside my BGP address family IPv4. I need to enable my interfaces. First interface is E00 on the outside. And I'm going to put this into the FVRF 16.6. No shot. And then I'm going to create a loopback as well. And the loopback, again, I'm going to put into FVRF. This is the one that I'm going to forward through BGP. 10.666.255.255.250. So those are the two interfaces in the VRF. This is again going to be for reachability. That's the only part of my network that I'm exposing with my service provider. 65006. Address family IPv4, VRF, FVRF, and my remote device is 16.1, and the AS number is 100. That's all I need to set up over here. The rest of it, you can just get rid of. So let's check this and see if it works. So I created the VRF over here, put the two interfaces, the physical interface between the PEC and a loopback that I'm going to use for my town source down destinations, and advertise that. Oh, I need to advertise that yet. In my BGP, so my provider edge now knows about this 10.6 network, but that's the only one that I'm exposing. So I'll go to router 6 and set this up. That's okay, that's okay. So now if everything is fine, I should have a neighbor that comes up. There you go. And on router 1, if I check my VRF, I should have that 10.6 network propagated. Brilliant. So my PE, CE on between R1 and R6 is set up. Now that I've set that up, I need to just replicate that for 7, 8, 9, and 10. So I'll just copy this over here. R7. We'll put this as 67:1. VRF, this is going to be 27:7. The one that I'm advertising, that will be my tunnel source tunnel destination for my DMVPN 10.7. This is 67.0.0.7. This is going to be 27.2, router 2, and I'm advertising 10.7. Change is done. Go to 7 now. So this should set up my relationship with R2. Give it some time. There you go. Show IP route VRF, FVRF. There you go. That's your 10.6 there. So now I can go trace using VRF or ping using VRF, FVRF, so that I have that loopback to loopback reachability. 10.7.7.7. There you go. That means my relationship is proper. Copy this for 8. $65,008, 38.8 now. I'm on router 8. This is 8.8.8 on the 10 network. This is 8.38.3. Remote AS is the same, and advertise 10.8. So again, the purpose of the loopback networks is the tunnel source tunnel destination for my DMVPN. That's the only thing that I'm going to expose towards my E routers. So let's just do this on 8. And while it's going it and getting connected, I can work on 9. There you go. The neighbor came up over there, and my 9 will be ready. 49.9. Advertise 9. This is 49.4. This is 9. And I'll paste it and then come back and verify 3. So while it's coming up, I can go to 8. Show IP route, VRF, FVRF. Okay, good. Ping 10.6.6.6, source, actually, VRF. I'm on 8. Something wrong. Ping VRF, FVRF. There you go. And I should be able to go to 10.7. And I'm on 8. Should be able to go to 9 if 9 has come up. That will also verify 9 for me. There you go. So on 9, show IP route, VRF, FVRF. There you go. 6, 7, and 8. 9 is myself. The last one is 10. So let's just do 10 now. And we can move on to DMVPN right after this. So 10, 65.0.0.10. We said 55. Say 10. Loopback that I want to advertise is 10.10.10.10. The AS number is 10. 55.5 was the address. 10.10. That is our 10 now. It's good. And if this works, you're good to go. So at this point, I have that loopback that I'm going to use for my tunnel networks. And again, the objective of doing this by running the FVRF, I'm completely isolating the network in terms of the routes that are visible to the service provider, the PE router. It's just that one loopback. I can have multiple networks now underneath, and I'm going to run that through DMVPN. Initially, I'm just going to do it clear text, and then I'm going to encrypt it using IPsec. Again, if you need more details about how DMVPN is set up, the concepts of that, there's another video that I have on my channel that goes into details about DMVPN itself. So looks like my BGP neighbor relationship is up. So I have all the routes. Let's just ping 10.10.10.10. It has to be done with VRF. So just want to make sure that everybody is communicating. Brilliant. So now that is done, I can now move on to my DMVPN part. In the DMVPN part, I'm not going to do another video. I'm just going to include it in as part of this. I'm going to set up this as my next hop server, which is R6. So from that perspective, from DMVPN's perspective, I'm R6, which is a hub or the headquarter site. This is the service provider cloud. I'm going to set up R7, R8, R9, and R10 as my clients. I'm going to register all the clients to the next hop server. I'm going to run DMVPN phase 3 with NHRP redirects. Again, take a look at my DMVPN videos for more details about what phase 1, phase 2, phase 3 do. So I'm doing phase 3 over here. So how do I set up my next hop server, and how do I set up my interfaces? Now my interfaces on each site are going to be 2 loopbacks, loopback 1 and loopback 2. I'll keep the 192.168 network over here. Let me write them down over here for you guys. So I have 2 internal loopbacks that I'm going to use. 192.168. Let's say 6.0 and 172.16.6.0. So these are my 2 loopbacks over here. Similarly, I'm going to have 192.168 7.0 and 172.16.7.0 over here. 192.168 8.0. 172.16.8.0. 2 private networks. Looks good. 9.0. This is done, and the last one now. Okay, these are my internal networks that I don't want R2, R1, R2, R3, R4, and R5 to be aware of. My tunnel network, my DMVPN network over here, between them, is going to be DMVPN, a common network of 192.168.1.0. So all these devices on the tunnel will be part of this network. So let's color it with a different color. Let's say blue. This one over here. There you go. I used blue already. Let's use red. There you go. Stands out. So that's going to be my DMVPN network. With this guy being the NHS, I'm running DMVPN in phase 3. That's my objective over here. So the next hop server is going to be that. So to set that up, that's going to be my next step over here. Step 3 now. So step number 3 is configure DMVPN between customer sites. Use R6 as the NHS. Use DMVPN phase 3. Use EIGRP AS100. What else? That should pretty much be it. So create an internal VRF to segregate the internal networks from the PE-C networks. So I'm not even making it aware of the other side. So on R6, I'm going to create another internal, I'll say. I don't need an RD for this one because I'm not running BGP, I'm running EIGRP. This is good enough. Just enable address family IPv4. And my interfaces that I'm going to have, I don't have a physical one. I am going to have two loopbacks. Loopback 1 is part of internal. And that network happens to be 192.168.6.6. And I am going to run, as promised, 2, which is 172.16.6.6, and my tunnel interface tunnel 1, IP address 192.168.1.1.6, I'll say. Tunnel source, I'm going to say loopback 0. That's the FVRF loopback. And in order to use it, I need to say tunnel VRF, FVRF. So basically use the FVRF for my tunnel source, tunnel destination. This is not the VRF of my tunnel, but it's the VRF for my reachability. My VRF for the tunnel is going to be internal. So I have 3 networks on the internal loopbacks and the tunnel network. The tunnel VRF basically is for reachability. Tunnel forwarding is the actual VRF that the tunnel belongs to. So this takes care of that for and tunnel mode. GRE multi-point. Now I can focus on my NHRP part. Network ID, enable it. IP NHRP, map, multicast, dynamic, IP NHRP, redirect for the phase 3. Because I'm going to be running split EIGRP, I need to disable split horizon over here on the hub. EIGRP, let's say 100, and that should do it for the tunnel over here. And then my router EIGRP, because I'm going to be running it in a VRF, address family, IPv4, VRF, internal, autonomous system, 100, and then my auto summary network is 1.0 and 6.0. I can just do 16.0.0. That will help me on the other side. So that should pretty much do it in terms of the config over here in R6. This is my next hop server. So let's just copy this, 16.6 internal, 72.16.66 tunnel. We are forwarding internal, 192.168 tunnel source, tunnel VRF, FVRF, the mode, NHRP, map multicast, phase 3, and split horizon and the mode, and my routing protocol. Copy. Let's go to router 6 and see if it takes. Definition, loopback 1 done, loopback 2 done, tunnel done. No problems. Looks like it's working properly so far. Now, what do I do on the client side, which is R7? Let's take a look. So this is okay. I can define it. Loopback, I'm going to change the address to 7.7. Loopback 2 again, 16.7.7. Tunnel source or tunnel IP is going to be 7. Loopback is the source. This is fine. This is fine. Now I am the client, so I need to point to my server. NHRP NHS is going to be 10.6.6.6. That's the IP address of my other side, the NHS, because the tunnel source is going to be the loopback of the other guy. To reach that, map 10. Actually, sorry, take that back. This is going to be the tunnel IP, which is 1.6. In order to reach there, I'm going to use the public or the outside address of 10.6.6.6, which is the tunnel source of the other side, and map multicast. I'm also going to point the multicast, which is EIGRP, to this guy. I'm a client, so I don't need to do the redirect. I need to do shortcut. I'm a client, I don't need to do the splitterize. This guy is required to run on this network, 7 network, and the 16 is good. So looks good. Let's try. Let's give it a try. Copy it. Let's go to 7. So if everything's fine, my tunnel should come up on R6. Show IP route VRF internal, and I just do a qualifier for EIGRP. So 172.16.7 and 192.168.7 are visible on R6. And if I go to 7, show IP route VRF, and I'll do internal, just qualify for EIGRP. 16.6 and 192.168.6.0 is there. The good thing about this is whatever configuration I did on 7, I can just copy it, just make a subtle couple of changes, and I should be good for 8 as well. So what are the changes? First thing is my address over here. It's going to be 8.8. 8.8. That's my tunnel IP. This thing remains the same. And this one over here, I'll change this to 8. All right, let's just check. If 8 comes up, there goes my tunnel. And there's the EIGRP, show IP route, VRF, internal, EIGRP. By doing this, I've completely hidden my internal networks from my service provider. So if I go to the service provider and check customer A, he'll just see those extra loop, the outside loopbacks. He has no idea about the 192.168.6, 172.16.x networks. Again, let me go through 9, and when I do 9, I'll explain these commands and the purpose of each command over here. So I'm creating a internal VRF that will keep my internal networks internal, segregated on the CE router as well. On 9, my internal network is 192.168.9.9, and this guy, loopback 2, is 172.16.9.9. All right, tunnel. VRF forwarding, that means this interface belongs to this VRF, which it needs to be part of the same VRF as the internal loopbacks. Give it an IP because all these 4 or 5 devices, 6, 7, 8, 9, and 10, are part of the same tunnel network. So one of them is .6, .7, .8, .9. Now, tunnel source is loopback 0. That loopback 0 is the only network that is available on the outside. That's the tunnel, the actual, normally this would have been the public network, the public address. In our case, it's not the public, but the outside network, the front door VRF. So this guy is not in my internal VRF. This guy is in the front door VRF. So So when you specify a loopback that is not part of your actual network, the way you have it check it is by using the command tunnel VRF FVRF. So basically it says tunnel source tunnel destination reachability for my tunnel or the source and destination is going to be done by checking my outside routing table, which is FVRF, the front door VRF. I'm running MGRE, so that's the mode change. Network ID, it just enables NHRP on that interface. So I'm doing that. My next hop server is 192.168.1.6. That's the tunnel IP of my NHS. How do I reach 192.168.1.6? Using this outside address, which is reachable via the front door VRF. And even if a multicast comes in, send it to 10666. Then my EHRP part, the only thing I need to change is 9 over here, and my router 9 will be done as well. So now every command that you put in under the tunnel is explained. So let's go to 9 now. Done. Loopbacks come up. Show IP route VRF internal. So 172.16, and we'll just qualify with the EHRP. 6, 7, 8, 9 is myself. I'm not learned through EHRP. 6, 7, and 8. If I check my front door VRF, I will only have that 10.6, 10.7, 10.8, 10.9. All right. So now if I want to ping, for example, 192.168, I need to put the VRF over here. Using the internal VRF, I want to ping 192.168, 6.6. Source I'm going to use is 192.168, 9.9. There you go. My ping is working. It's going through the tunnel. If I do a trace route over here, the trace route will only show one hop. So trace VRF is internal. I want to ping 192.168. I'll do the same one. Or let's do 7. 7.7. Source is going to be 9.9. It goes through 6 and 7. That's the first time because I'm running phase 3. The second one should go direct. So now I'm running phase 3. That shows you the phase 3 part of it as well. So 9 is done. And the last one now, router 10, and we will have our network up and running. The only thing that will be left is the encryption part of it. Again, I'll show you the commands to do it. The explanations, if you take a look at my DMVPN video, they're over there. So this network over here is 10.10, 10.10, 192.168, 1.10. This part is the same. And this network over here is 10. Brilliant. Copy. IP route, VRF internal. There you go. Just do couple of traces, or just do a ping. 192.168.6.6. Source is 192.168.10.10. Is it? Oh yeah. Ping VRF internal. There you go. Let's also ping 7, 8, and 9. All right. So my reachability has been established between the CE routers, although the B routers right now, which are R1, have no idea about these networks. They only know about those loopbacks based on which I set up my DMVPN network. But again, it's still clear text. So the last step over here that I'm going to do is to encrypt it. Again, as I said, you can get the actual explanation of the DMVPN part, including the encryption, in my DMVPN video. My objective over here was more to show you how to combine the two technologies. So individually, you would need to know those technologies. I just modified it a little bit to show you a particular scenario that can really help you in your actual implementations in a work environment, especially from the enterprise perspective. Configure, let's say, IPsec to secure the tunnel interface, because it is hidden, but it is sent in the clear. So if somebody's sniffing the traffic, they would be able to reach it, read it. So I'll just do, it's the same config, it's a common config for all of them. So step one is, this is IPsec, phase one of IPsec, crypto ISACAM policy, and auth free share. I would recommend doing RSA signatures, but for the purpose of demonstration, this is good. Hash is MD5, let's say group of 2. My key, crypto ISACAM key, says Cisco 123, address 0000. That's why I recommend using certificates instead. I don't want to keep a wildcard key, but it's still okay. IPsec, transform-set, ABC, ESP triple des, ESP MD5 HMAC. Recommended to do more transport to cut down on the overhead of duplication of the headers. IPsec profile is my third step. Crypto IPsec profile, whatever you want to call it. iProf set, transform set, I call it ABC. Step 4, apply the tunnel interface. And because I've kept the same tunnel number, I can use the same configuration in all of them. Tunnel protection, IPsec profile, iProf. And this is the same config, common config that will go on to all my CE routers. So let's start with 6. My tunnels will come down because I'm doing encryption over here. Now, before I was not. There you go. 8, 9. The neighbor's gone down. That's okay. Once I do my encryption on all 4 of them, the neighbors will come up and they'll be doing EIGRP. So, IPsec. I go over here, show IP EIGRP, or check the routes now. VRF internal EIGRP. Still down. The tunnels come back up. Oh yeah. Don't forget about, don't worry about doing this, because in order to do that, I need to do the ISACAM profile. That is another topic, which is VRF aware VPN. So skip that. It becomes another topic. Probably another video for VRF aware VPN. Shouldn't have done that, but that's okay. So my EIGRP route should be coming back. Six is myself, 7, 8, 9, 7, 8, 9, 10 are there, 7, 8, 9, 10 are there. So again, the purpose over here, the only reason the IPsec did not work, there is a special configuration called the VRF aware IPsec. We'll probably do that in another video. Over here, what I've done is I have these 2 networks, which are my internal networks. I want to hide them from my service provider. So what I did was I set up a DMVPN tunnel based on a loopback that I created that I shared with my MPLS service provider. I set my DMVPN based on that. That part was done in a VRF, which was on the outside towards the service provider. This is known as the front door VRF, or the FVRF. I created a separate VRF for the tunnel itself and the internal network called the internal VRF. In terms of reachability of the tunnel, it's done through the front door VRF. The tunnel itself will be in the internal VRF. And how did I tell the tunnel to use the outside VRF, the front door VRF, for reachability? I'm going to take this out over here. I don't need this. This is, again, as I said, another topic. So the way I did that was by using the tunnel VRF command. Tunnel VRF basically tells it that, hey, listen, tunnel source, tunnel destination are reachable via the VRF called FVRF. That's the purpose of the tunnel VRF command. VRF forwarding basically specifies the actual VRF that the tunnel is part of. All the routes in that VRF will be available for routing. I hope you enjoyed the video. Again, to take full advantage of this video, prior to looking at these two videos, take a look at the MPLS VPN video that I have. That'll give you insights, more details about how to set up an MPLS VPN setup over here. And also take a look at my detailed video on DMVPN. That will give you an insight of how to set up DMVPN. My objective was to combine the two in conjunction with the front door VRF over here with the internal VRF. And by doing this, I've hidden my internal routes from my service provider. Hope you enjoyed it. Keep watching. I'll be posting other videos on this channel.